This is section 5.1 continued, and we are working with the normal distribution. So in our last lesson, we learned how to find probabilities from a z-value using our table. Now we're actually going to start with our original x value that can have any normal distribution. Then we'll change it to a z-value, and then we'll use the table to find the probability. So for example, in example 7, we have IQ scores are normally distributed with an average of 100 points and a standard deviation of about 15 points. A person with an IQ score of 130 or higher is considered gifted. So what is the probability that a randomly selected person is gifted? So the first thing we need to do is write down what they give us. So we know that it's normal, we know that our mean is 100, and our standard deviation is 15. So we're looking for the probability that a person is gifted, which means that they have an IQ, which we'll say X is their IQ, that is greater than or equal to 130. First thing I need to do is change this to a z-value. The formula for z-value is that it's X minus the population mean divided by the population standard deviation. It is greater than or equal to 130 minus my mean of 100 over my standard deviation of 15. Now that I have my x minus mu over sigma, notice that is equal to z. So this changes now to the probability that z is greater than or equal to 2. Now I always like to draw pictures for these. So here's my z equals 2, and I'm looking for the area to the right. Now you'll notice as you come to your normal table and look at your normal table that it always gives you areas to the left. So when I look up z equals 2.00, that the area it gives me is 0.9772. But that is the area to the left. If I want to get the area to the right, then I have to do 1 minus 0.9772. Which gives me 0.0228. Now just so that you are aware, many times the books will use this notation. So when I looked up the area to the left of 2, that was the CDF evaluated at 2. And remember that the CDF for the standard normal distribution is the uppercase phi, so we could say like phi of 2 equals 0.9772. So lots of times they'll write that the probability that z is greater than or equal to 2, they'll say that's just 1 minus phi evaluated at 2. So that is just some alternate notation, but our final answer was 0.0228. And just make sure before you try and find any probability for normal distribution that you standardize. You find your z-value. Okay, so example A, automaker A claims that the mileages of its mid-sized cars are normally distributed with a mean mileage of mu equals 33 and sigma equals 0.7. Assume their claim is true, so assume those numbers are correct. Calculate the probability that the mileage, x, of a randomly selected mid-sized car will be between 32 and 35 miles per gallon. So we're looking for the probability that x is between 32 and 35. Now remember, for a continuous distribution, it doesn't matter if this is a less than or equal to or a less than, because the probability at any single point is 0. So if I want to do this problem, I have to standardize both values. So I'm going to do 32 minus my mean of 33 over 0.7 less than or equal to, it's again x minus the mean over the standard deviation less than or equal to 35 minus 33 over 0.7. Now because I have subtracted the mean and divided by the standard deviation, those are no longer x values, but they are z values. So z is between negative 1.43 and 2.86. Now we've done a lot of problems like this with our CDFs and using our CDFs, and I could evaluate this at the CDF for z, which is the uppercase phi, of 2.86 minus the CDF evaluated at negative 1.43. So we need to come to our table, so I want 2.86. So I go the 2.8 and cross the top to get my hundredths place. Puts me at 0.9979. Minus, and now if I go to find my negative 1.43, negative 1.4, go across the top until you get to your hundredths place of 3. So negative 1.43 puts me at 0.0764. Which gives me 0.9215. If I was to draw the picture for this, because I like the pictures, here's my negative 1.43, here's my 2.86, and I'm looking for the area in the middle. So what I did is I found all the area to the left of 2.86, found all the area to the left of negative 1.43, and subtracted to find the area in the middle. Okay. Notice what we did in this problem follows this formula from the book, but we didn't have to memorize a formula that looks fairly technical. But my b minus mu over sigma, that was my 35 minus 33 over 0.7, which gave me my 2.86, so we had phi of 2.86 minus phi of a minus mu over sigma, so 32 minus 33 over 0.7. For this next problem, if x is normally distributed with a mean of 2.5 and a variance of 9, then that means my standard deviation is 3. We want to find the probability that the absolute value of x is less than or equal to 3. The easiest way to do this is just get rid of the absolute values and rewrite it as negative 3 is less than or equal to x less than or equal to positive 3. And from here, it's exactly like what we did previously. So this is the probability. We need to standardize both values. So negative 3 minus 2.5 over 3 less than or equal to x minus mu over sigma less than or equal to 3 minus my mean of 2.5 over my standard deviation of 3. So this becomes the probability that z is between negative 1.83 and 0.17. And then if I was to draw my picture, here's my 0.17, here's my negative 1.83, and I'm looking for the area in between. So I need to find all the area to the left of 0.17, all the area to the left of negative 1.83, and subtract to get the area in the middle. So if I look up 0.17 on my chart, z equals 1.7. 0.1 and go over to the hundredths place for 7, so 0.5675. And then go back and look up my negative 1.83. So negative 1.83 gives me 0.0336. Which equals 0.5339. Okay. Next example. Marketing research indicates that hot chocolate tastes best if its temperature is between 153 and 167 degrees Fahrenheit. A restaurant claims that their hot chocolate has a mean of 160 degrees and a standard deviation of 5.37 degrees. Estimate the probability that X, the temperature of a randomly selected cup of hot chocolate, is outside the optimal temperature range. Now, first of all, the book that I copied this from didn't state that this was normally distributed, and I can't do the problem unless it's normally distributed. I would have no idea what the temperature what the distribution of the temperature would be. And so this problem would be impossible if I didn't know that it was normal. So let's assume that it's normal. We're looking for the probability that the temperature is outside that range, which means that x is less than 153 or x is greater than 167. To do this, I just start and I standardize both values. So it's the probability that x minus the mean over sigma is less than 153 minus my mean of 160 over my standard deviation of 5.37. Or I need to do the same thing, so it's going to be 167 minus 160 over 5.37. So this gives me the probability that z is less than negative 1.30 or z is greater than 1.30. Now when you look at your chart, here's my negative 1.30, here's my 1.30, and we're looking for the area in the left tail or the area in the right tail. So let's look for the area to the left of negative 1.3 first. So I'm looking for 1.30, so 0.0968. And then due to symmetry of the normal curve, if that area is 0.0968, then this area is also 0.0968. So my total area is 0.0968 plus 0.0968, which gives me 0.1936. We're going to skip the next two problems, but I will work them out on the PDF so that you can look at them later. So on example 11 that we skipped working out together, the probability is 0.8389, and for example 12, the probability is 0.0889. For our next topic, we have knowing probabilities and finding z-values. So it's basically the opposite process that we've gone through. So before we found z-values and then we found the probability, now we'll know the probability and try and find the z-value. So we define z alpha to be the z-score that has alpha area to the right. So if this is my z critical value, then the area to the right is alpha. And let's change that, that's not accurate. Phi of z alpha equals 1 minus alpha. Because if the area to the right is alpha, then the area to the left is 1 minus alpha. So for example 13, I want to find the z-value that has 0.2 area to the right, which means we have 0.2 area to the right, and I am looking for this z-value that makes it happen. Now the first thing that I do is I say, okay, the area to the right is 0.2, but that's not going to help me because my table only gives me areas to the left. If the area to the right is 0.2, then the area to the right, if the area to the right is 0.2, the area to the left is 0.8. So what I'm going to do is I'm going to go to my standard normal table and look for 0.8 in the middle where the probabilities are. Okay, so in the middle I'm looking for my 0.8. It's not going to be on there exactly, I'm just going to look for the closest possible value I can come to. So 0.7995 is the closest value I can come to. So then my z-value is 0.84. And that's it. Okay, so for the next example, find the z-score that has a combined probability of 0.10 in both tails. So that means I have this tail, I have this tail. If I have 0.10 in both tails, then that means each tail actually only gets 0.05. And I am looking for the z-value. This would be positive z, this would be negative z. So what I'm going to do is, I know the table gives me areas to the left, so if I look at this 0.05, it will tell me what the negative z-value is. So I'm looking for 0.05 in the middle of the table. Notice it is exactly midway between 0.0505 and 0.0495. So I'm going to go with a z-value of negative 1.6, and that's between the 4 and the 5, so I'm going to go with 1.645. Now, if you just decided to go with negative 1.64 or negative 1.65, both of those answers would be correct because neither one was closer. But I am going to go with negative 1.645. So if this value is negative 1.645, then this positive z-value is also 1.645. So z equals 1.645. Example 15, if z is normally distributed 0, 1, find the value of z that satisfies each equation. So the first one is we're looking for the area for z greater than or equal to z, so that would be the right tail, and we want that area to be 0.39. And we're looking for the z-value that makes that happen. Now again, if there's 0.39 area in the right, then that means if I use the complement rule, 1 minus that, I get that the area to the left is 0.61. Again, important because my table only gives me areas to the left. So I'm looking for 0.61 area to the left. That will be on the second page of my normal table. I'm looking for 0.61. It's the probability, so it's in the inside. It looks like the closest I can find is 0.6103. So my z-value is 0.28. So z equals 0.28. For this next problem, the probability that the absolute value of z is greater than or equal to my specific value is 0.72, and I'm looking for that specific value. So if it's the absolute value of z is greater than or equal to, that means we're looking for the area in both tails. Because we could rewrite this as the probability that z is greater than or equal to z, or z is less than or equal to negative z. So that's why it's the area in both tails. Well, if the area in both tails is 0.72, then that means the area in this tail has to be 0.36. And the area in the right tail has to be 0.36. So I'm going to look at my 0.36 on my table. Again, it's the probability, so I'm looking on the inside. And it looks like the closest I can come is this 0.3594, which puts me at negative 0.36. Okay, so that's just a very strong coincidence, very unusual. So z equals negative 0.36, so negative z is negative 0.36. So this is my negative 0.36, this is my 0.36. So I'm going to say z equals 0.36. Again, that was very unusual that my z value and the probability ended up being the same. Example 16. Mensa is an organization that provides intelligent individuals an opportunity to meet other smart people at a local, regional, and national levels. The Mensa website does not specify what IQ score a person must obtain to be admitted. Instead, it states that the society welcomes people from every walk of life whose IQ is in the top 2% of the population. What IQ score must I have to be admitted to Mensa? Remember that our IQ scores are normally distributed with a mean of 100 and a variance of 15 squared, which means that my standard deviation is 15. So what we want is we're looking for the x value. So x greater than or equal to my specific x value, I don't know what, is 0.02. So we want to know what do I have to be in the top 2%. First thing I need to do is find the z value. Okay, so I know my probability is 0.02, I'm looking for the z value. Now 0.02 is to the right, and that means 0.98 is to the left. This will be on my second page of the standard normal table. I'm looking for 0.98. Looks like the closest I can come is this 0.9803, which means my z value is 2.06. Oh, nope, that's not my closest. My closest is 0.799798. So my z value is 2.05. Z equals 2.05. What I really need is the x value, but we know this formula. We know that z equals x minus mu over sigma. Well, at the moment, I know my z value. I don't know my x value or my IQ score, but I do know my mean is 100, and I know my standard deviation is 15. And what I have to do is I just solve for x. Okay, so x is going to equal 2.05 times 15 plus 100, which gives me 130.75. So if you want to be in Mensa, you have to have a score of at least 130.75. For our next example, extensive testing indicates that the lifetime of the Everlast battery is normally distributed with the mean of mu equals 60 and a standard deviation of sigma equals 6. Okay. They're going to offer a free replacement battery to any purchaser whose Everlast battery does not last at least as long as the minimum lifetime. How can the manufacturer establish the guarantee period so only 1% of the batteries have to be replaced free of charge? So if you think about it, so it's the actual lifetimes that are normally distributed that we're looking at, and it's the batteries that have a short lifetime that have to be replaced, and we only want to replace 1%. So it's the batteries so it's the batteries that have the shortest lifetimes that have to get replaced, so that means I want 0.01 area in the left tail. And I need to find that z value. So z value with 0.01 in the left, it's going to be, this is the closest value. So z is negative 2.33. Okay, again we know our formula, z equals x minus the mean over sigma. So we have negative 2.33 equals our unknown lifetime x minus the mean of 60 over the standard deviation of 6, and solve for x. So 46.02, so you need a lifetime of at least 46 months. Okay, sorry. They want to make the guarantee 46 months or less, so they only have to replace 1% of the batteries. We're going to try the next two examples on your own, and then we will compare our answers to see if you get the same thing. So try it on your own, pause it and try it on your own. So as I went through this problem, I found my z of 1.28, x is 645.8, which means you have to score at least 645.8 to be in the top 10%. Now, just so you're aware, many times when you get to this statistics level, because we know that the capital phi of x is the CDF for our standard normal distribution C, what they'll do is when you're looking for the C value, you'll use the inverse phi. So inverse of phi of 0.10 will equal your z value. So if you see that notation, that's what they're doing. They're just looking for the z value, and that's why it's phi inverse. And for our last example, I found a z value of negative 0.67, which when I then solved for x, that gives me an x value of 537.83. So to be in the bottom 25% of students, you need to get 537.83 or worse.